A 3-meter deck is built around a square pool. Find the dimensions of a square pool if the area of the pool and the deck measures 324 meters squared. First, let's draw a diagram. In the diagram, the x represents the width of the pool, while the 3 is added to each side to represent the additional width of the deck. We can now state that the width of the deck is equal to x plus 6 by adding both 3's. Do this for each side, width and length. Now that that's out of the way, let's start with some equations. With the given knowledge that the area is equal to 324 meters squared, and also knowing that width times length is equal to the area, we can say that x plus 6 times x plus 6 is equal to 324 meters squared. Let's simplify x plus 6 times x plus 6 to x plus 6 squared. Then, using the square root principle, we can root both sides. This gives us the equation x plus 6 equals plus minus 18. Don't forget the plus minus. This equation gives us two answers. Our first answer is negative 24 and our second answer is 12. Now we must decide which answer is the right answer. We know logically that a pool side cannot have a negative length, so we can go ahead and eliminate negative 24. So the pool length must be 12 meters long. A rectangular piece of metal measuring 30 centimeters by 20 centimeters is made into an open box with no lid. The box has a base area of 459 centimeters squared and is formed by cutting squares of equal size from each corner of the piece of metal and bending the sides up. Find the length of each side of the squares that were removed. So first, let's draw a diagram of the question. Here we see the 30 by 20 centimeter piece of metal, and each square in the corner, both length and width represented by variable x. Because we're looking for area, let's start with the equation length times width equals area. Knowing that the base area of the box is 459 centimeters, let's replace A for area with 459 centimeters squared. Looking at the width of the final base area, we can see that it will be equal to the 30 centimeters of the initial width of the box minus both x's on the squares. So we can write that as 30 minus 2x. Then we can plug that into the formula. Once we've done that, we can do the same thing with the length, subtracting the 20 centimeters of the initial length by 2x, and also plug that into the formula. This gives us the formula. 30 minus 2x multiplied by 20 minus 2x is equal to 459 centimeters squared. We can now expand the left side of the equation. This is starting to look a lot like a quadratic. So let's move the 459 over to the left side and make the right side 0. So we can insert it into a quadratic equation to solve for x. Okay, let's start putting everything into the quadratic equation. Looking at these values, we can make our a value equal to 4, our B value equal to negative 100, and our C value equal to 141. Alright, let's go ahead and put all these values into the quadratic equation. Okay, we can now use our calculators to simplify the equation. This equation is going to give us two answers. Our first answer being x equals 23.5, and our second answer being x equals 1.5. Because logically we cannot cut 23.5 centimeters off of a 20 centimeter wide box, we can go ahead and eliminate x equals 23.5. This gives us our final answer of x equals 1.5, or the length and width of the boxes being cut out of the side of the piece of metal, to be 1.5 centimeters in length.